Hello everyone. In physical pharmaceutics, we have started first unit, that is solubility of drugs. In previous class, we have seen some definitions like solubility, solute, solvent, saturated, unsaturated, supersaturated solution, molality, normality. Then what are different percentage expressions like percentage weight by weight, percentage weight by volume, percentage volume by volume. Then some solubility expressions according to different pharmacopoeias like BP, USP and IP. Then quantitatively how solubility will be expressed like molality, normality and percentage expressions. According to IP and USP, solubility of solute divided into 7 parts. According to IP, suppose 1 gram of solute is dissolved in 1 ml of solution. It is called as that solute is called as very soluble, and as per USP, 1 part in 1 ml. Like that, 1 gram in 1 to 10 ml freely soluble, or 1 part in 1 to 10 part is freely soluble. Like that, 7 categories are there: very soluble, freely soluble, soluble, sparingly soluble, slightly soluble, very slightly insoluble, or practically insoluble. After that, we have to see the solubility process, or how solute will interact with the solvent. In solubility process, there are 3 steps. In first steps, what happens? Removal of molecules from the solute phase at a definite temperature. Bond between adjacent molecules are broken down and molecules become free. Suppose this is a solute. From this, some molecules will get separated. The bond between intermolecular bond between the molecule, intramolecular bond between the molecule solute will broken down, and some solute will get free. In second step, what happens? There is creation of holes in the solvent, just large enough to accept the solute molecules. अभी जो सॉल्वेंट मॉलिक्यूल है उसमें कुछ होल्स क्रिएट होते हैं और cavities are created. Those cavity will capture these solute molecules. Now both A and B, जो A and B both are work done on the system, means system के ऊपर work हो रहा है, so they consist endothermic reactions, means energy will be utilized here. Now next, in third step, what happens? The placement of solute molecules in the hole of solvent. जो होल्स रहते हैं, कैविटीज रहते हैं, उसमें वो सॉल्यूट कैप्चर होता है. Okay, this is last steps involve work done by the system and involve exothermic reactions, means here energy will be released. If net work done by the system is more, means जो भी last step का work done is more, then solubilization occurs. If last steps work done by the system is more than first 2 steps A and B is more, then solubilization will occur. Thus, increase in temperature of solution promotes the solubility. We have seen that in uh, last step involves the exothermic reactions. It involves the release of energy. Suppose we increase the temperature of solution, that will promote the solubility. Okay. Now coming to how solute will interact with solvent, it is based on the like dissolve like principle. Means polar solvent dissolves the polar solute, whereas non-polar solvent dissolves the non-polar solute. Simple. The solubility of solute mainly depends on nature of solvent, polar or non-polar. First, what will happen? Cleavage of solute-solute interaction bond, means bond between solute-solute will be broken down. Then cleavage of solute and solvent intermolecular bond. When अब जब ये सॉल्यूट को सॉल्वेंट में डालते हैं तब कुछ बॉन्ड्स क्रिएट होते हैं सॉल्यूट और सॉल्वेंट में, वो बॉन्ड्स भी ब्रेक होते हैं सेकेंड स्टेप में. देन फॉर्मेशन ऑफ कैविटी इन सॉल्वेंट फेज. Earlier we have seen that cavities are formed in the solvent phase. Now, next step is movement of solute into the cavity of solvent phase, and finally formation of solute solvent intermolecular bond. After solute transfer to the cavity of solvent phase, there will be a formation of solute solvent intermolecular bond that will leads to the solubility of solute. Next, suppose X is a solvent and Y is a solute. There are three forces of attractions are represented by here. X means force of attraction between solvent itself. Y means force of attraction or bonding between solute itself, and XY is the bonding between solute and solvent. Now there are three conditions are mentioned here. Suppose bonding between solute solvent molecule is greater than the bonding between solvent and solute, then they will remain immiscible, or solvent will not dissolve the solute. Here two example is given: benzene and water. Benzene will not be miscible with water because the bonding of what we can say, the benzene molecule bonding is greater than that of water, or water molecule bonding is greater than of benzene, so they will not miscible to each other. In second step, the bonding of solute itself is greater than that of solvent XX. एग्जाम्पल इज सोडियम क्लोराइड इन बेंजीन. जो भी सोडियम क्लोराइड के सॉल्यूट के बॉन्ड्स रहते इटसेल्फ, वो बेंजीन सॉल्वेंट से भी ज़्यादा रहते हैं. दैट्स वाई सोडियम क्लोराइड विल नॉट डिजॉल्व इन बेंजीन. इन थर्ड स्टेप व्हाट हैपन्स, the intermolecular bonding between solute and solvent is greater than that of solvent itself and solute itself. एग्जाम्पल सोडियम क्लोराइड इन वाटर. जो भी सॉल्वेंट और सॉल्यूट के बीच में जो बॉन्डिंग रहता है वो ग्रेटर रहता है सॉल्यूट और सॉल्वेंट इटसेल्फ से. दैट्स व्हाई sodium chloride will dissolve in water. Now here one chart is there, like dissolves like. Suppose solute is ionic, then here in this column solute is given and here solvent. If solute is ionic and solvent is polar, then it will get solute will get soluble. If solute is ionic and solvent is non-polar, it will remain insoluble. Like that, if solute is polar and solvent is polar, it will remain soluble. If its solvent is non-polar, insoluble. If solute is non-polar and solvent is polar, insoluble, and solvent is non-polar, then soluble. Means ionic and polar substance will soluble in polar solvent, whereas non-polar solute dissolves in the non-polar solvent. Next, classification of solvent for the solubility solubility. How solvents are classified? Now they are classified in three categories. Polar, based on the polarity they are classified. One is polar solvent, second one is non-polar solvent, third one is semi-polar solvent. Now for first one is polar solvent. In that examples are water, glycol, methyl and ethyl alcohol. Now polar solvent usually they contain hydroxyl groups, and their mechanism of solubility is based on four categories. First one is high dielectric constant, means attraction between opposite charge molecules. Now these molecules contain some charges. This means they having negative charge OH minus group they contain, that will attract to the positive charge molecules. So that leads to the solubilization of solute. Higher dielectric constant they contain. Second one is hydrogen bond formation. Water dissolves alcohol, aldehyde, ketone, phenol through this mechanism. Now, hydrogen bond formation, there is a bond formation between hydrogen atom of water molecule and oxygen atom of alcohol or aldehyde or ketone. This hydrogen bonding also leads to increase the solubility of solute. Now, third one is dipole interaction where water dissolves ionic solutes through this mechanism. And last one is Bronsted-Lowry type of protonation reaction where electron donor receptor actions which enhance the solubilities. Means electron donating or accepting will leads to formation of bonds which leads to increase the solubility of particular solid if that solute is acid or base. Now, second category is non-polar solvent. Example for that carbon tetrachloride and benzene. Other solvents are also there. They are used to dissolve vegetable oils since vegetable oils are not soluble in water. Now, mechanism non-polar solvent dissolves non-polar solid or liquid. They are aprotic solvent. Aprotic means they does not contain any hydrogen atom and cannot dissolve polar solute and ionic compounds. The solutes are kept in solution by London type or van der Waals process. Now, van der Waals process are not a chemical or ionic process. They are weak process. They show some weak attractive or repulsive forces which leads to the solubility of particular solute. Now, third one is semipolar solvent. Example for that ketone and alcohol. They are intermediate between polar and non-polar. वो दोनों के intermediate रहते हैं. They will not be a polar, fully polar or non-polar. This solvent induces certain amount of polarity in non-polar solvent. Means they act as a co-solvent. They induces some amount of polarity. Means they will add some polarity into non-polar solvent so that whatever non-polar solute which not dissolves in that solvent will get dissolved. Now next is solubility parameter. Now solubility parameter is used to check the extent of solubility. To estimate the solubility of ideal solubility parameters are used. It is a numerical value of extent of solubility. कितना solubility हो रहा है solute का और how much capacity of solvent is there for solubilization of any solute. It will checked by the solubility parameters. Mathematically, it is given by delta value. Solubility parameter is defined as square root of the density of energy of cohesion of substance. Now, it expresses cohesive forces between the molecules. Cohesive forces between the molecules. Molecules, either they may be solute molecules or solvent molecules. Now, what is cohesive forces? Cohesive forces means attractive forces between like molecules. So, solubility parameters expresses the cohesive forces between the molecules. अगर ज़्यादा cohesive forces है in solvent, then that solvent will not dissolves the solute properly. If solute having stronger cohesive forces, it will not also get dissolved properly in solvent. So to express those cohesive forces, solubility parameters are used. It is given by Hildebrand solubility parameter, that is square root of cohesive energy delta equal to square root of delta HV minus RT divided by Vm, where delta HV is the heat of vaporization, R is a gas constant, T is the temperature, Vm is the molar volume of liquid at desired temperature. Now delta indicates the solvency behavior of specific solvent. Okay. Next is they may serve as a measure of internal pressure of solvent and solute. As earlier I told, delta indicates the cohesive energy, means they will measure the internal pressure of solvent and solute. How much cohesive strength is there in solvent and solute will be denoted by the delta value. Unit of delta is calorie per centimeter cube in bracket raised to 1 by 2, and in SI unit it is joules raised to 1 by 2 meter raised to minus 3 by 2 equivalent to Pascal raised to 1 by 2. Suppose the value of delta 1 for solvent and delta 2 is for solute, then difference between these two gives the extent of solubility. Now delta 1 minus delta 2, difference between these two will gives the extent of solubility. Suppose the difference is 0, then that solution is called as ideal solution. If that difference is nearer to 0, then it is called as non-ideal solution, and extent of solubility of solute will be high in that type of system. Now another solubility parameter is Hansen solubility parameter. It is given by delta T square equals to delta D square plus delta P square plus delta H square. This Hansen solubility parameter also used to check the extent of solubility of solute or extent of solubility behavior of solvent also. It depends on the three parameters. First one is dispersion component of solute. Next one is polar component of solute or solvent, and hydrogen bonding of component between solute and solvent. This is about the solubility parameter. Now next we have to see the some applications of solubility parameters. In that, first one is selection of solvent for maximum solubility. Now during selection of solvent for maximum solubility, we have to see that more like the value of delta between solute and solvent, there will be a greater mutual solubility, because more like means delta 1 and delta 2 values are similar, then the delta 1 minus delta 2 becomes 0 or nearer to 0, then maximum solubility will occur. So selection of solvent also based on the solubility parameter. Next one is selection of co-solvent for increased solubility. Now co-solvent are the blend of solvent to enhance the or increase the solubility of non-polar substances. Solvent are arranged on the basis of polarity. Now by using that polarity scale, co-solvents are used to increase the solubility of solute. Third one is chemical kinetics. Now polar solvent tends to increase the rate of reaction where compared to non-polar solvent due to high internal pressure. Thus they are used in the chemical kinetics, study of chemical kinetics. Solubility parameters and drug action. Now solubility parameter appropriate for the biological membrane or delta value appropriate for the biological membrane. Thus solute will enter the biological membrane. अगर solubility parameter biological membrane को appropriate है तो वो drug molecule biological membrane को cross करता है, and that drug molecule will show the proper drug action. Fifth one is solubility parameter and SAR. some molecules structurally modified so that they will show pharmacological action. Now modified structures have higher solubility than that of parent molecule, which leads to increase the concentration of drug at the site of actions, and ultimately it leads to more drug action. Next one is solubility parameter and drug transport through the model membrane. Now drug transport through the model membranes are lipoidal barriers. The smaller the difference between lipoidal molecular membrane and drug molecule will leads to faster transfer of solid molecules across the membrane. Next one is solubility parameters, also used in biopharmaceutics. Biopharmaceutics studies involves the application of dosage form in living organism, like drug absorption, dissolution studies. All those studies solubility parameters also use. Now, coming to next point of the topic, solvation and association. What is solvation? It is a process of surrounding solute particle with solvent to form the solution is called as solvation. Means यहाँ पे क्या होता है, जो solute particle रहता है वो surround किया जाता है किससे, solvent molecules से. Solute particle will be surrounded by solvent molecules. That process is called as solvation. If solvent is water, then that process is called as hydration. अगर वाटर सराउंड कर रहा है, suppose any solid particle is there that will be surrounded by water, then it is called as hydration. Now interaction between solvent with the solute, which leads to stabilization of solute. Stabilization of solute कब होता है, जब total interaction of solvent and solute. The strength of interaction may influence the properties of solute, including solubility, reactivity and color. जो भी properties रहते हैं solute के, solubility, reactivity and color, that will be influenced by this strength of reaction. Now that strength of reaction involves bond formation like hydrogen bonding, van der Waals forces, or dipole-dipole or dipole induce. Now what is solvation energy? It is amount of energy related with the dissolution of solvent or to form the solvation of solute. It is the amount of energy related with the dissolution of solute. If it is positive number, dissolution process is endothermic. If it is negative, it is exothermic. Now next is solvation number, which describes the number of solvent molecule bounds to the solute species. Suppose here sodium ion we have taken, and it is surrounded with the 5 molecules of water. So solvation number of sodium ion is 5. Means it describes the number of solvent molecules bound to the solute species. जो भी solute species है उसको कितने molecule ने surround किए है, that will give the solvation number. Now steps involved in solvation are detachment of solute from the bulk. Whatever steps are there in solubility process, same steps are here, because solvation is nothing but again solubility. Just you see, first step is detachment of solute from the bulk. Second step is formation of vacant site in solvent, and third step is insertion of detached, मीन्स जो भी फर्स्ट स्टेप में डिटैच सॉल्यूट रहता है वो वैकेंट साइट में इंसर्ट होता है थर्ड स्टेप में. Now this is diagrammatically how solvation will be occurred, shown here. Here solute molecules, it will first, in first step what happens, solute molecules, the bond between the molecules will get disturbed, and solid molecules will get free. In second step, solvent molecule will form some cavity, and this solid molecule will get inserted in these cavities to form the solution. This process is also called as solvation or dissolution. If positive solvation energy will be there, then that will be a endothermic, and if it negative solvation means exothermic, where energy is released. Now, what are the different factors affecting to solvation? Surface area. If more surface area of solute, it will interact more with the solvent, leads to higher surface area for the solvation. Second one is agitation. If more agitation will be there, more solute molecule comes contact with the solvent molecules, that will increase the solvation. Third one is heat. If more the heat or increase in the kinetic energy will increase the solvation. These are the three factors: surface area, agitation, and heat affects the solvation. Next one is association. Association is different from the solvation. In association, what happens? It is chemical reaction where opposite charges come together in solution to form different chemical entity. Means here different chemical entity will be formed in the solution where opposite charges are comes together. Ions of opposite charges are naturally attracted to each other by electrostatic force, and it is given by Coulomb's law. Now Coulomb's law is F equal to Ke into Q1 Q1 into Q2 divided by epsilon r square, where F is the force of attraction, K is the association constant, Q1 and Q2 are the magnitude of electrical charges on the ions, epsilon is a dielectric constant of the medium, whereas r is the distance between charged ion. जो भी अपोजिट चार्ज आयन उस सिस्टम में रहते हैं, जो naturally attracted with by the electrostatic force, their strength is or force of attraction is given by the Coulomb's law. Now those ions either will be dimer, trimer, means दो आयन अट्रैक्ट होते हैं तो उसको डाइमर बोलते हैं, तीन आयन ट्राइमर, फोर आयन tetramer, like that. Now how the type of association will be there? First one is contact, second one is solvent separated, and third one is fully separated. In contact type of association, what will happen? Here red color suppose is a positive charge and blue color indicates the negative charge. These both ions will comes together and they are in contact with each other. So this is called as contact type of association, whereas solvent is surrounded by these ions. Okay, in second solvent separated, what happens? These ions are not in contact with each other, but they are separated with the solvent. So it is called as solvent separated or solvent shared. And third one is fully separated, means these ions are fully separated and they individually uh, what we can say, they individually separated with the solvent surrounding. Individual आयंस को इंडिविजुअल सॉल्वेंट मॉलिक्यूल सराउंडिंग रहता है एंड दे आर फुल्ली सेपरेटेड. So these are the three types of ion association: contact, solvent separated, and fully separated. Now, what are the factors affecting to the association? It is magnitude of charge and distance between the ions. As we have seen that in Coulomb's law, If suppose magnitude of charge uh, on the ions is higher, automatically force of attraction will be increases. And distance between the charged ions, if distance between the charged ion is more, then again force of attraction will reduce. If it is less, force of attraction will get increases. Now this is all about the solubility process mechanism of solute solvent interaction. In that we have seen how solute will interact with the solvent, what are the different types of solvent, uh, polar, non-polar, and semi-polar solvent. Then we have seen that solubility parameters, in that Hildebrand parameter, then Hansen parameter, then application of solubility parameters, then what is solvation, factors affecting solvation, then association, and what are the types of association and factors affecting association. In next lecture, we will see the quantitative approach to the factors influencing solubility of drugs and diffusion principle in the biological system. Thank you.